Generics allow developers to create really flexible code which works with multiple types while still providing type safety for specific types. Consider the filter function we created previously. We had to use any type when creating this function, and any type for the callback function that we provided. In doing this, we effectively lost all type safety we had when invoking it. However, if we look at the built-in filter function, it actually has really good type support, and if we hover over this food variable, it even seems to know exactly what type that food variable is. The way this is achieved is through the use of generics. Let's see if we can use generics in our filter function to replicate the same level of type safety that's being done in the built-in filter function. To make a function generic, after the function name, we're going to do angle brackets, and we'll specify a generic character that we want to use. This character T could be anything. The most common ones are probably going to be T and E, T being a generic type, and E being a generic element. But in theory, you could use pretty much whatever you want here. Now, what this does is it gives us access to some type T, which will be replaced with an actual type when we go to use this function. So currently, our array is any type, but when we go to use this function, we know that it will be some specific type. Maybe it will be a number array, maybe it will be a string array, maybe we'll have created some interface or class and it will be an array of those objects. What we're saying in our generic case is that it's going to be some type T, being the same type T we defined here. Now in our should keep callback function, we know that the element passed to that callback function will be of the same type as the array provided. So this element will also be of type T. And then the last thing we know is we're only filtering elements. So the return type for our function will be the same as the input type, which means the return type is also going to be TArray. And then inside of our function, where we're creating that result, we don't need to use any type anymore. We can say it's of type TArray. So if we hover over our method signature now, we see that filter array will take in some type T. It will invoke a callback function and pass an element of that type to that callback function to determine if that element should be kept or removed. And then the function is going to return the result, which is going to be an array of the same type that was provided as input. To demonstrate the generic nature of our function now, let's create a new array with some random numbers and apply a filter to it. We'll create an array, const some numbers, and we'll assign it some values. Let's assume that we want to filter any number that's less than 20 out of this array. So we'll create a new variable, filtered results, and we'll invoke our filter array function where we'll provide it with some numbers as the first argument. And then in our second argument, we're going to create our callback function to determine if the number should be kept or not. This will be provided with an element. And what we said we want to do was filter any number less than 20. So to do this, we need to return true if the element is greater than 20. So we'll say Ellie is greater than 20. Now, if we hover over our code, if we hover over the parameter Ellie, it seems to know now that Ellie is of type number. And if we look at the variable we created, it also knows that the type for this variable is a number array. That's because this filter array function is returning a number array in this specific scenario. If we come back up to our other array, we can define an interface for these food ratings. So I've gone ahead and done that. I created the interface, which has food of type string, rating of type number, and our food ratings is now a food rating array. And when we use our generic function with this array, we'll say const filtered ratings equals filter array. We'll provide our food ratings as input. And then in our callback function, we'll be provided each individual rating. And in this scenario, we'll keep the food rating if the rating is greater than 8. Now, if we hover over this, we see that the rating is of type food rating, not of type number now. And it knows that because we provided a food rating array as the first parameter. We also see that the type for our filtered ratings is a food rating array as well. What's going on here is when we created the function, we specified a generic type t, saying we don't know what type we're going to be provided, but it will be some specific type. Now, none of the logic inside of this function actually cares what type of element we use. So what TypeScript is doing is, based on the first parameter we're providing, it's inferring that t is that type. So in our first example, because we provided it a number array, t was replaced with number. In our second example, because we provided it a food ratings array, t was replaced with food rating. And to confirm this works, let's go ahead and console log both of these, run our code, and make sure it's not broken. So we add the console logs, we run the code, and we get 25 and 500 for our first array, and then our second array we only get toaster strudel. This makes sense, as 25 and 500 are the only numbers above 20. And in our food ratings, toaster strudel is the only item with rating greater than 8. Cheese not included, because it is rated exactly 8, and we said greater than, not greater than or equal to. Let's go ahead and try to create a set again. And remember, when we created a set, we used the brackets to say what type of items we were going to store in the set. If we hold Control and we click the set, we can actually go into the documentation for it and notice that the set is an interface which uses generics. Because it uses generics, the set doesn't need to care what type of items we're going to provide to it. All it needs to know is that we will provide some type, and it can give us type safety for then working with that specific type. So in the case of the set, we have some type t. When we add items into the set, it knows that the item we're going to add must be of type t. When we check if an item exists in the set, it knows that those items also must be of type t. And if we remove an item from the set, it knows that we need to remove an item of type t. Generics are honestly a pretty complex topic, and I don't fully expect you to understand them at this point. I hope you can see the value that they provide and why they're so crucial to things like data structures such as sets, maps, and arrays. You might be wondering, when are you supposed to use generics in your code? And to be honest, you probably won't be using generics all that much in code you write. The scenarios where generics are most useful is when you're creating libraries or frameworks that will be used by multiple other developers in multiple other projects. If you're using generics within your own project, I would consider it probably a slightly more advanced use case.